Imagine you applied for a job as a Java developer and company says that along with a Java development you will also need to manage the server, then design the UI and design the marketing strategy. So you will say, is this a Java developer role or any other role, right? This is not a correct Java developer description, or you can say the correct JD for this Java developer role. You will say this is a torture, right? That's exactly what fat interfaces does to your Java classes. They possess classes to implement the methods that they don't need. So the interface segregation principles comes into the picture to fix this problem. So welcome back to Code with Aditya. In this video, we will cover the interface segregation principle and how it helps us to solve the fat interface problem. So let's go. So here, according to the ISP principle or interface segregation principle, so no class should be forced to implement methods it doesn't use or it doesn't need. What is this? So let me explain you. Instead of one big interface, create a smaller or you can say a specific interface having a specific methods. So that is the meaning of the ISP, or you can say the interface segregation principle. So let's take an example. I have one interface having a three methods like work is there, eat is there, sleep is there, and for this interface I have created a one implementation class. The class name is human worker, and here I have implemented a three methods. The first one is work is there, second one eat is there, and the third one sleep is there. And all the actions are relevant to human worker. Like human worker can work, then they can sleep, they can eat, right? Then I have created a second implementation class which is a robot worker. Here I have implemented a work method. Then here we have the eat method and sleep method, but as you can see I am throwing a unsupported operation exception. Why? Because robot cannot eat, robot cannot sleep, only robot can work, right? So these two methods are irrelevant, but that we know that in interface we have added this to abstract method, so that particular implementation class needs to add a body here. So according to the ISP, we are forcing the robot worker class to implement this method which is not relevant to this class. Here we are breaking the interface segregation principle, because as you can see no class should be forced to implement methods it doesn't use. So here we are violating the ISP principle. So in next code we will see how to fix the ISP principle in the same code only. So let's go. So first we will create, or you can say, smaller and specific interfaces for the specific work. So first create a one interface. Let's go with the workable. So I will add a name here as a workable, and this one is interface. In workable interface I will add a one method which will be the work method. Okay, then we have the second action eat. For the eat I will create a one more interface. Let's name this as Eatable, and this one is the interface, and here I will add a eat method. Then next action we have sleep. So for the sleep we will create again a different interface, and I will name this as a sleepable. You can give a name like sleep, sleepable. Okay, so here I will add a sleep method. Okay, so according to the ISP principle we have achieved the first thing. Instead of creating a one big interface, create a smaller and specific interfaces. So here we have the one big interfaces. So out of this one big interface we have created a smaller and specific interfaces. Then we will create an implementation class. So first we will create a human worker. So here I will implement a workable interface. Then I will implement the Eatable as well. Then the last one is sleepable, because human can sleep, humans can eat, and they can work, right? So that's why I have implemented a three interface here, and here I will add a method as well, and here we will print human can eat. So same we can print here as well. You can add your logic as well if you want, but just for the understanding I'm printing. So human can sleep, human can work. Okay, so this is the one implementation class we have. Then we'll create a second implementation class. So it will be a robot workers, and here we will implement workable. Okay, because a robot can only work, right? So that's why we are implementing only the workable interface, and here we will print robot can work. Then we will create a one main class to run this program. Let's give the name as a main, and we will add a main method here, and here we will create an object. So human workers hw is equal to new human workers. Then we will call the methods. The first one is work, second one we will go with the eat, and the last one we have sleep. Okay, then we'll create an object for the robot workers as well. Rw is equal to new robot workers, and in robot worker we will call the work method, and first we will run the program. So as you can see, we are getting the output, whatever thing we have added in that particular methods, so we are getting here, right? So here as you can see, the robot workers, we are implementing only the relevant method, that is work. We are not adding a sleep and eat method, right? So in the first program, as we can see here, robot work needs to implement all the method, means in this class we are forcing to implement the other methods as well, which is not relevant to this class. So using ISP we have achieved the same thing. So we are just implementing the methods or features which are relatable to that particular class. So here we have achieved the ISP principle. So this is, you can say, ISP principle or interface segregation principle from the solid principles. So in the next video we will cover the last principle from the solid principle. So thank you.